Welcome to The Explainer. I am beyond excited to dive into today's topic with you. We're looking at something genuinely fascinating: how Elon Musk's companies are aggressively moving from theoretical, pie-in-the-sky designs right down to physical, tangible hardware milestones. We are talking about the actual nuts, bolts, chips, and rockets that are going to fundamentally change our reality. We aren't just discussing abstract ideas today, we're watching blueprints become actual reality right in front of us. Here's our roadmap for today. We'll start with the hardware revolution down in Texas, explore AI5 powering Optimus, and look at the cybercab rethinking manufacturing. Then we'll blast off to Starship V3 in space, before tying the whole shebang together in the big picture. Let's get right to it. Section 1. The hardware revolution begins. Okay, let's dive into this because this revolution doesn't actually start with a car or a rocket, but inside a massive semiconductor plant in Texas. We need to talk about a highly technical term that represents a huge milestone, and that term is tape-out. Basically, this is the exact moment a chip design is totally frozen and handed off for physical manufacturing. Think of it like handing a finished architectural blueprint over to a construction crew so they can finally start pouring the foundation. Recently, in a really fascinating reveal, an 18-year-old Samsung principal engineer named James Kim shared that they have officially completed the tape-out of Tesla's next-generation AI5 chip. This means the factory is primed and ready to adapt Tesla's design, which was finished up back in April, to its own production equipment down in Taylor, Texas. And this is a massive undertaking. We're talking about part of a $16.5 billion deal signed last year to build these insanely advanced chips right here in America. Section 2. AI5, powering Optimus robots. So you might be wondering, why does Optimus even need a brand new chip? I mean, Tesla already has incredibly advanced computers inside their cars, right? Well, Elon Musk has repeatedly pointed out that their current computer, the AI4, actually already has enough raw power to make full self-driving safer than a human driver. And if you look at Tesla's unsupervised robotaxis operating in places like Texas and Miami, that really seems to track. They don't desperately need the AI5 in their cars right this second. Instead, they're aiming this ultra-powerful new chip at two much larger opportunities: massive AI training computers, and of course, the Optimus robot. And this brilliantly illustrates exactly why it needs so much power. It all comes down to the environment. A car, for the most part, operates in a highly structured world. It's got painted lanes, speed limit signs, and predictable traffic lights. It kind of knows what to expect. But a humanoid robot, that thing has to work in pure chaos. Imagine it trying to navigate a messy living room, picking up oddly shaped objects, dodging a running toddler or a pet. Processing that unpredictable, completely chaotic environment in real time, whether that's on a busy factory floor or eventually in our own homes, requires just a mind-bending amount of computing power. But here's the catch. Massive computing power creates a massive physical bottleneck, and that is battery life. Just like your smartphone, Optimus has to carry its own power supply. But while a Tesla Model Y lugs around a massive 75 kilowatt-hour battery, Optimus has a tiny 2.3 kilowatt-hour pack. That is literally 32 times smaller. If the computer alone drew the kind of power it does inside a car, the robot's battery would drain flat before its motors even twitched. So the crucial point is that Tesla had to do what it does best: optimize with absolutely ruthless efficiency. They managed to bring the power draw down to a mere 250 watts. How? By literally evicting any single part of the chip that wasn't earning its keep. You know, standard chips have graphics processors for video games or image processors to make your selfies pop. Tesla ripped all of that out. Nothing is wasted. They replaced that space with hardware built purely to run their own neural networks. It's literally the difference between a robot dying before its lunch break and one that can work an entire shift on a single charge. But supporting a future filled with working humanoid robots requires a scale of manufacturing that frankly just does not exist today. The current semiconductor industry can only produce a fraction of the AI chips Tesla expects to need. And that brings us to plans like the proposed Texas Terafab project. Involving Tesla, SpaceX, xAI, and Intel, this facility is expected to span roughly 100 million square feet. To put that staggering number into perspective, that is the size of Vatican City, Monaco, and Gibraltar combined. It's set to be the largest chip factory ever attempted in human history. Section 3. Cybercab, rethinking car manufacturing. 287,000 tons. That staggering number, straight from the EPA, is the amount of volatile organic compounds emitted every single year by auto body shops, just from painting cars. That accounts for 2.5% of the total VOC emissions for the entire country. Normally, building a car means sending parts to a paint shop to be sprayed, where they literally just sit and off-gas harmful chemicals for hours. Now, what's incredibly interesting here is how Tesla is bypassing that entire toxic process with the Cybercab. As revealed in their 2025 impact report, they're transitioning to something called reaction injection molding, or RIM. Instead of shaping a car part and painting it later, they literally inject the colors straight into the mold while the part is being formed. It comes out completely finished, no paint job, no toxic fumes. They've taken a process that usually takes hours and shrunk it down to minutes, all while cutting paint pollution by 35%. And that efficiency hits the pavement too, aiming for a record-breaking 165 watt-hours per mile. Tesla's VP of Vehicle Engineering confirmed this number, making it the most energy-efficient vehicle they have ever produced. Now, why is it so efficient? Well, Tesla looked at the data and realized what we all kind of already know from taking an Uber. 85% of ride-hailing trips only carry 1 or 2 people. So instead of hauling around an empty 5-seater, they built a lightweight 2-seater. No steering wheel, no pedals, no mirrors. It sheds all that weight to become remarkably efficient. And it's expected to avoid nearly twice the greenhouse gas emissions per mile of a Model 3 or Model Y. Section 4. Starship V3. Real Space Work. Let's move up to orbit and see how this builds into Starship's upcoming Flight 13. Because they aren't just testing anymore, they're doing real work. First up, they're ditching the dummy payloads and deploying 20 actual next-generation Starlink V3 satellites into space to test high-capacity laser links. Second, SpaceX is intentionally painting several heat shield tiles white to simulate damage. Why? To train their onboard cameras to spot real, actual danger while in orbit. And third, they are attempting to restart a Raptor engine in space. That third objective, it is absolutely critical. Firing a rocket engine on the launch pad is one thing. Restarting one in the freezing, microgravity vacuum of space is vastly more difficult, because the fuel essentially floats and behaves entirely differently. But it is mandatory. During the previous flight, SpaceX faced issues with engine relights. Flight 13 is designed to prove that their updated hardware and software have solved this once and for all. Because without microgravity restarts, orbital refueling is impossible. And without refueling, getting to the moon or Mars is, well, literally impossible. This is the exact hardware test needed to unlock an interplanetary future. Section 5. The Big Picture. So, how do all of these distinct milestones, a chip factory in Texas, a molded car door, and a rocket engine relight in orbit, actually connect? They all tie together through a unified, long-term technological blueprint envisioned by Elon Musk. It's like a giant puzzle. Today, we have AI4 safely operating cars. Next, that newly taped-out AI5 chip brings all-day battery life and incredible brain power to the Optimus robot. Moving into the future, AI6 will scale up massive AI training systems, but the true endgame, that's AI7. Musk envisions physically placing Tesla's AI hardware right into orbital satellites. Up there, they can harness completely abundant solar energy and use the freezing cold vacuum of space as a natural zero-energy cooling system for planetary-scale AI workloads. Every single battery tweak, every rocket launch, and every chip factory is just one step on this massive roadmap. Which leaves us with this final provocative thought to consider today. We've seen how these aren't just software updates. These are massive physical hardware milestones. From pouring concrete at Texas foundries to injecting zero-waste molds for cars, right up to orbital engine relights. These things are happening right now in the real world. So how quickly will these tangible milestones completely rewrite the reality of our daily lives? From how we commute, to the robots building our everyday products, to the satellites processing our data high overhead, the blueprint is drawn and the builders have already started. Thank you so much for joining me on The Explainer today, and keep your eyes peeled because our reality is changing fast.